Hey, good evening, my friends. Welcome to the last session for this sprint for grade 12 board exams today. So I'm sure that you enjoyed all the previous sessions and really excited for this one as well. For the newcomers here, this is Bhavdeep Sethi. I'm a physics master teacher at Vedantu. If you have not seen all these past classes, if you were absent in those or you did not have information about it, please do make sure that you see them. They are really going to help you out. Today is our last day. We are going to do modern physics part 3, which includes semiconductors. Semiconductors are the reason you and I are conversing right now, by the way. All these computers, electronic devices, mobile phones, it's impossible without these semiconductors here. Plus the communication system. So that combined here. So before we get started, make sure that you have subscribed to the channel, press the bell icon so that you can get notifications about the upcoming awesome courses that the team is designing right here. Please also share this information about the free education with everybody. These courses are free and will always be free. So the strategy today is, again, as always, simplification. Whatever you thought, is going to be simplified here. Because if it isn't simplified enough, then you're not studying it the right way. अगर ये पढ़ रहे हो तो the procedure itself is wrong. The teaching procedure is not right. So we are going to simplify everything what you thought here. So why board exams? Today is the last session, so I'm going to repeat this for the 11th time, that 75% marks are needed if you're thinking of IITs, NITs or centrally funded engineering institutes. And if your board gives you percentiles, you have to be in top 20 percentile there. For medical students, you need 50% in physics, chemistry and biology combined. But more important than that, which I highlight every time, is clearing the concepts. When you're studying for competitive exams, shortcuts, elimination and all these, eliminate this choice, you're not studying everything, because you can still get through that. And that is not a bad thing. But what I'm trying to emphasize is clearing concepts is going to help you in the long run, whether or not you take physics in your college as a major, but this is going to help you in life also. So clear the concepts. How do you clear the concepts? Derivations, long explanations, all these are done only in the board exams. So that is the reason I'm asking you to emphasize on your board exams for next few weeks here. And then you'll have enough time for your NEET and JEE April exam. No, don't worry. But for now, focus and fully clear all your concepts. Clearing concepts is going to help you in the competitive exam. कॉन्सेप्ट क्लियर हो गया कि भाई ऐसा क्यों हो रहा है, ऐसा क्यों हो रहा है, देन यार सारे ही क्वेश्चन इजी है ना, फिर शॉर्टकट्स लर्न करना है फॉर स्पीड, दैट्स ऑल. So what is in store today? Today we are going to talk about the semiconductors, transistors, diodes, everything around us is all semiconductors. These light bulbs, LED bulbs, everything is semiconductors. 12 number की आज बात हो रही है, 12 marks. So we were studying optics. We studied in ray optics one day, wave optics the other day. दोनों का मिला के 14 था. That I said is maximum. But today's concepts here, क्योंकि 7 number का semiconductors आएगा, and then we are also doing communication systems today. That is going to be 5 marks. So 7 plus 5 is 12 marks is what we are talking about today. So we are doing communication systems also. Now as always, ये जो highlighted होता है second वाला, that is specific to this chapter. So input output characteristics, you have to really understand. Rectification नहीं, you have to understand those graphs of input output characteristics. अगर ये कर लिया, then you can explain what is transistor, how is it used as amplifier, how is it used as switch. You can understand anything. Input output characteristic, that is, if you have to understand one thing, like focus more on this, is the input output characteristics graph. अगर ये नहीं करे, then you're memorizing things. अभी याद है, कल याद नहीं है, आधा याद है, 1/4 याद है, 90% याद है, नहीं, पर ये पता है तो सब पता है. तो emphasize on this one thing for this chapter. All derivations, as always, have to be completely understood, not memorized. Because when you do the derivations using a plain sheet of paper, books दूर रख दी, plain sheet of paper, take pen and paper, try to derive yourself. You should be able to derive anything, then you are there. The next level comes from the back exercises of NCERT. NCERT book is the king for the board exams. So you have to do all the back exercises without referring to any of the solutions. Solutions are available at vedantu.com. Please feel free to download them, but only after you've already tried those. And if you're stuck up, refer to them. Otherwise, use them to match your solutions. Past 5 years question paper, at least 5-year question papers. More the merrier, but at least 5-year question papers. Do not refer to the solutions, do them yourself, then go back and check the solutions or the marking schemes. Solutions and papers are available at vedantu.com, your one-stop solution to any of your preparations for board exams and competitive exams. So the right way to understand this, as I've already said, the analogies that we do with the mechanical world around us, and we have seen that in electrostatics also, this analogy is going to help you a lot. Transistor hai ye, transistor. This is the emitter, this is the collector, and this is the base. इसको इस तरह से समझो, self analyze करो. I'm not going to teach you today. Analyze yourself. Emitter, that's the source of charges. Collector is the drain where the charges are going, and the base is actually the switch over there. That says, okay, chalo jao. So try to analyze your transistor with this picture here. You can take a screenshot if you want and self-explain. अपने आप को पढ़ाओ यार, अपने आप को पढ़ाओ. That's the best way to learn. Now the question number 1 here says, what type of charges are left near or on either side of the junction diode? What is the junction diode? It's a PN junction. मैं briefly cover करूँगा, very briefly, because of the lack of time. I'm going to cover very briefly how this all happens. So PN junction, we are not going to do in detail. PN junction, you take one side, you inject impurities to make this P type. P type is what? Holes. है ना? And then N type is what? Electrons. अब क्या chemistry में पढ़ा था? Diffusion. What is diffusion? When there is a lot of atoms here or molecules here, they are going to diffuse into low density area. That's exactly what happens. Some books say positive charges, negative charges attract. नहीं. That's not what is happening. What is happening is diffusion. Majority, बहुत सारे diffuse होंगे, ये उधर diffuse होंगे तो क्या होगा? यहाँ पे इस एरिया में इलेक्ट्रॉन तो वो यहाँ आ गया, तो यहाँ नेगेटिव चार्ज बन गया, तो यहाँ पॉजिटिव बन गया. ठीक है, मोर इलेक्ट्रॉन्स डिफ्यूज हो रहे हैं, यहाँ नेगेटिव और हो गया, यहाँ पॉजिटिव और हो गया. जब ये हो रहा है तो व्हाट इज गोइंग टू हैपन नाउ? Positive, negative. There is an electric field that is getting built up here, positive to negative. But electric field, think about negative charges, they get force in the backward direction. So more electrons trying to come here, they're going to face resistance by this electric field. But electrons say, nahi, I can still do that. There are some electrons, they can still do that. But when they do that, the electric field gets stronger. बाकी और रुक जाएंगे, फिर भी कुछ और आ जाएंगे. It keeps building up until that activity reduces to very minority level. So the diffusion current has reduced, not zero, it has reduced. The current is still there because electrons going this way, there is a diffusion current going this way. Try to understand this chapter like this. ठीक है? और क्या होगा? Atmosphere, ये जो room temperature, that is going to break one of the, so electron hole pair is created, let's say here, because of thermal agitation. There is electron hole pair created here. Now electron will go in this direction because it's in an electric field. Electron goes this way, hole go this way, but that means there's a current flowing this way. Now electrons are going that way. This is the drift current, my friends. That was the diffusion current. There's another current which is called the drift current. I'm just covering this in 2 minutes, so that this is just a pointer how you have to understand this chapter. So now what is happening? There's a diffusion current because these are still diffusing, but then because of thermal agitation, once in a while electron hole pair is created. There's a drift current. In equilibrium, this equal to this, and that is why there is no charge flowing, net charge flowing. Current is still there, net current is zero. अब इतना सब क्यों बताया? इतना सब इसलिए बताया कि if you can analyze this way, all the upcoming questions are going to be very easy for you. So let's look at this. What type of charges are left near or on either side? ये positive ions हो गए, negative ions हो गए. That's all. They are not free charges. Free charges थे, but those free charges थे, है ना? अब नहीं है because they are gone now. तो उसको frame कैसे करना है आंसर में, ये देख लो. Use the word diffusion. है ना, क्योंकि all this is happening because of the diffusion current. So you are supposed to use those words, diffusion current, in this. So let's go to the next question here. Define AC signal amplification factor. So briefly cover कर रहा हूँ, again very brief introduction. This is not a full course. I'm just trying to briefly introduce you. There is a transistor here. We're talking about transistor here, right? So let's take a transistor. है ना, this is the emitter, this is the base, and this is the collector, है ना. Now let's make a quick circuit here with common emitter. Common emitter से क्या होगा? Some of the electrons, let's say this is NPN type, electrons go in. 100 electrons go in there. Let's say 100 electrons go in there. What would happen is couple of them, एक या दो यहाँ पे आ जाएंगे, 2 electrons come out here. बाकी के सारे उधर चले जाएंगे and 98 come here. Now electrons are charges, so the rate of flow of charge is the current. What we are talking about is there is some emitter current that has been split into base current and the collector current. Law of conservation of charge is what we are talking about. So what we can guarantee that emitter current is always going to be equal to collector current plus the base current. This is guaranteed here, and a law of conservation of charge. अब हुआ क्या यहाँ पे? 100, 98, 2. Now when you try to analyze all these amplification factors and all, you need two very basic ratios here. Note it down. You should have already studied this, but let's see that what is alpha. Alpha is about how much is the collector current for a unit of emitter current. Okay, and when you're talking of dynamic scenario, it will be change in collector current versus the change in emitter current. Another ratio that is very useful is beta. That is how much is the collector current for the base current. And usually we're talking of changes there because we are talking about amplification. When I change beta, when I change the base current, how much does the collector current change? And you can clearly see 49 times. So beta here is 49, it's just an example. And this is exactly what they're talking about, beta. So you're supposed to respond this in your own words, obviously. So I'll just move out here so that you can see that. So this is just a sample. So always talk about deltas. You're not actually interested in the actual numbers there. You're more interested in the differences, the fluctuations. How much does the current change? When I'm changing the base current, how much does the collector current change? So you're always interested in the changes. You're not interested in the actual numbers in there. So the next question on the whiteboard, present a NOT gate. अब NOT gate क्या होता है? NOT gate क्या है? True दिया तो false आ गया, false दिया तो true आ गया, है ना? That's a NOT gate. NOT negate कर रहा है सब कुछ. True input दिया, एक input चाहिए उसको. If you give true, it gives you false. If you give false, it gives true. Now we are supposed to use NAND gate. What is NAND gate? AND gate plus the NOR gate. उसको यूज करके नॉट गेट बनाना एंड यू शुड बी कंफर्टेबल विद दीज एक्चुअली बिकॉज यू माइट सम ऑफ द स्टूडेंट्स माइट हैव टेकन कंप्यूटर साइंस आल्सो सो यू माइट आल्सो नो दैट बट लेट्स मेक अ NAND gate and try to understand how this works as a NOT gate. So let's make inputs here and let's say there is one input now. So there is one input A here. Now let's try to make the truth table or try to understand this. मैंने A को true कर दिया. If this is true, true. है ना? True and true is going to give me true. But that is going to negate that. It's going to make it false. So what happened just now? I gave true here. Ultimately I got false there. And let's try with false here. If I give it false here, false and false becomes false. But uska ulta, which is true. So I gave false here, it becomes true there. तो ये मेरा NOR गेट की तरह काम कर रहा है. दिस इज अ NAND गेट बट दिस इज बिहेविंग एज अ NOR गेट नाउ. सो लेट्स मूव ऑन टू द नेक्स्ट क्वेश्चन और बिफोर दैट लेट्स सी हाउ यू कैन दैट्स इट. तो ए बार ये NOT गेट बन गया तुम्हारा. ठीक है. विच मोड ऑफ प्रोपगेशन इज यूज्ड बाय शॉर्ट वेव्स ब्रॉडकास्ट सर्विसेज. शॉर्ट वेव्स रेडियो, राइट? रेडियोस क्या करते हैं? हाउ डू वी डू दैट? बेसिकली यू टेक इलेक्ट्रोमैग्नेटिक रेडिएशंस बीम कर दिया, ऊपर आयनोस्फीयर है, उसके अक्रॉस नहीं जा पाता. दे डोंट हैव सो मच ऑफ एनर्जी दैट दे कैन गो थ्रू दैट. उससे रिफ्लेक्ट हो जाएंगे. दैट्स ऑल दे डू. सो व्हाट इज हैपनिंग इज you're beaming the radiations. Let's think about radiations going up. There's ionosphere there. It's going to bring it back to the earth. And this is based on the reflection there. And this is exactly what these waves are using. So this is how you can present it. And this is how the FM radio and all these AM radios they use these. तभी वो सिटी में काम करते हैं, थोड़े आसपास काम करते हैं. You're not using satellites for them. You're making use of the reflection through the ionosphere. 5 नंबर का आता है कम्युनिकेशन. इट्स वेरी इजी. अ स्टूडेंट वांट्स टू यूज अ 2 PN junction diodes. What is a PN junction? PN junction can be used as a valve. Valve क्या होता है? One way flow. साइकिल के ट्यूब में हवा भरी, the air goes in, air cannot come out. That is a valve. हमारे हार्ट में valve होता है. Blood can go one way, it cannot come back. So that's a blood valve. Your water valves, water can flow one way, cannot come back. That's a water valve. इधर electricity की बात हो रही है. Electrons can go one way, cannot come back. That is PN junction, used as a valve now. So that's basically what you're talking about. Now alternating current. Alternating current इधर जा रहा है, इधर जा रहा है, इधर जा रहा है, इधर जा रहा है. You put a valve, जब इधर जा रहा तो जाने देगा, इधर जा रहा तो नहीं जाने देगा. That's what you're going to use this for. Alternating current fluctuates in direction. It tries to go this way. You have a valve. It says please go in, and then when it tries to go back, it says no, you cannot do that. And that's exactly what you're using there. So very briefly मैं पहले समझा देता हूँ, and then I'll show you how you can respond in the exam also. So 2 PN junctions use करने हैं. तो let's do step by step. ठीक है. मैं even though the question is not asking for half wave rectifier, let me explain you half wave rectifier also. So there is a transformer here. Transformer, as we have already seen, it will only work with alternating current because this is mutual induction. If the flux here is changing, flux here will be generated. We have already covered that. So this is alternating current. अब मेरे electronic devices will not work on alternating current. There is a big problem now. तो मैं क्या करूँगा? Half wave rectifier कर रहा हूँ. This is not the question. So what I can do is I can put a valve here. This is a valve, right? So there is something here, some device that needs current one way. तो मैंने इसको कनेक्ट कर दिया. Very easy now. See, if this is 0 volts and this is 12 volts, let's say, current goes in, है ना. नेगेटिव साइकिल में ये -10 माइनस वो जो भी होगा, करंट ट्राइज टू गो दिस वे, इट डजंट अलाउ दैट. इट सेज व्हेन दिस इज पॉजिटिव साइकिल द करंट गोज इन, नेगेटिव साइकिल करंट डज नॉट गो. सो दिस वाज योर इनपुट. लेट्स सी दैट दिस वाज योर इनपुट and your output will be all the positive cycles. It says okay please, yes, sure. Negative cycles को cut कर देगा. This is half wave rectifier. अब इसको next level पे लेके जाते हैं. इसको we'll make it a full wave rectifier. How? Very easy. Same procedure here. I'm going to use 2 PN junctions this time. और थोड़ा बड़ा बना देता हूँ, है ना, so that I can use more space there. अब 2 diodes. We are going to use 2 diodes. One diode इधर लगा दिया. कुछ भी memorize नहीं करना है इसमें, कुछ नहीं मेमोराइज करना. एंड देन दिस इज माय डिवाइस. लेट्स से दिस इज माय डिवाइस. ये सिंप्लीफाइड है. देयर कैन नॉट बी एनी सिंपलर सर्किट देन दिस. सो लेट्स टॉक अबाउट दिस. दिस इज 0 volts. इफ दिस इज 0 volts, लेट्स से दिस वाज पॉजिटिव 12 volts एंड दिस वाज पॉजिटिव 6 volts, है ना. अब देखो क्या हो रहा है. 12 is more than 6. If 12 is more than 6, the current starts, it tries to go this way and the current can go this way. The current is flowing this way. And 0 और 6 में compare करो, 6 is more than 0. So the current tries to go this way through this diode, but no, it cannot do that because it's trying to go in the reverse direction. So this is off. It is not helping now. Only this is participating and making sure that the current goes this way. अब negative cycle में जाओ, देखो क्या होगा. ये नेगेटिव कर दिया, इसको भी नेगेटिव कर दिया. अब नाउ लुक एट इट. -12, -6. -6 इज मोर देन -12. द करंट ट्राइज टू गो दिस वे, इट कैन नॉट. तो दिस वन इज ऑफ नाउ इन द नेगेटिव साइकिल. इसमें देखो, इन दोनों में 0 और -6 में कंपेयर करो, 0 इज मोर नाउ. सो द करंट ट्राइज टू गो दिस वे. अगेन द करंट इज गोइंग दिस वे. नाउ in the positive cycle, this is on, this is off. This is making sure the current goes through this. In the negative cycle, ये off हो गया, ये on हो गया. तो अब current is going in the same direction thank you to this. And this is exactly what is a full wave rectifier. तो ये मेरी cycle थी. अब cycle क्या हो गई? ये हो गई. ये दोनों बारी बारी काम कर रहे हैं. पहले पॉजिटिव साइकिल में इसने ऐसा किया, नेगेटिव ने इसने ऐसा किया. तो बेसिकली दे आर टेकिंग टर्न्स. अभी मेरी बारी, अब तेरी बारी, है ना. सो दिस इज अ फुल वेव रेक्टिफायर. द ओनली प्रॉब्लम यू कैन सी इज द पोटेंशियल डिफरेंस इज ओनली 6, बट देन यू कैन मेक इट 24 and 12. दैट्स फाइन. गिव द ट्रुथ टेबल फॉर अ नैंड गेट, है ना, वो कर लेते हैं. नैंड गेट क्या होता है? तो x और y दो इनपुट दे दिए. अब एंड गेट क्या करेगा? एंड गेट तो क्या करेगा? उसको एंड करेगा, है ना. 0 0 विल बी 0, 0 1 विल बी 0, 1 0 विल बी 0, 1 1 विल बी 1, है ना. अब नैंड गेट इसको उल्टा कर देगा, नैंड गेट 1 1 1 0 खत्म. So let's go to the solution for this, how you can present it. It's a 3-mark question, and I think this is what I wanted to show you. So bari bari they'll take turns. So let's see. I'll move out here so that you can see the full solution here. And again, this is a sample solution. You make your own solutions there. You write it in your own words. Do not memorize anything. Physics mein memorization will not help you. Understanding will help you. So this is the truth table. It's always a good idea to make the circuit diagram for that, also symbol for that. So let's go to the next question here. It talks about give 3 reasons why modulation of a message signal is necessary for long distance transmission. Modulation क्या है? You have some message you want to transmit. पहले तो ये चैप्टर ठीक से पढ़ो, ट्रांसड्यूसर क्या करता है. इट्स कन्वर्टिंग ऑल दैट इनटू इलेक्ट्रिकल सिग्नल्स. नाउ आई एम नॉट गोइंग इनटू मेनी डिटेल्स, बट देयर आर 3 रीजंस दैट आस्किंग. सो नंबर 1 रीजन आई जस्ट शो यू वेरी ब्रीफली so that you can never forget it. And why so? It's much beyond the curriculum here. So the length of the antenna has to be roughly 1/4 of the wavelength for effective transmission. That's the reason number 1 you should give. So जो लेंथ ऑफ एंटेना है ना, ट्रांसमिटिंग एंटेना, उसकी लेंथ शुड बी 1/4 ऑफ द वेवलेंथ. अब वेवलेंथ की बात करें हम, वेवलेंथ क्या है? वेवलेंथ इज वेलोसिटी डिवाइडेड बाय फ्रीक्वेंसी. वेलोसिटी कितनी? दीज आर इलेक्ट्रोमैग्नेटिक रेडिएशंस. 3 times 10 to the power 8 डिवाइडेड बाय कितना? ह्यूमंस कैन अंडरस्टैंड 20 हर्ट्ज टू 20,000 हर्ट्ज. मैक्सिमम ले लिया, जैसे वेवलेंथ और कम है 20,000, 4 zeros आ गए, 4 0 से 4 0 कट गए यहां से, तो क्या आ गया? 1 2 3 4 डिवाइडेड बाय 2, है ना. ये क्या आ गया? 15 किलोमीटर्स इज व्हाट यू आर टॉकिंग अबाउट. 15 किलोमीटर्स इज द वेवलेंथ. इफ यू डिड नॉट मॉड्यूलेट द सिग्नल, the highest frequency would have this wavelength. इसका 1/4 करो, 3.75 kilometers लंबा एंटेना चाहिए. Is it really practical? No. That is why what you do is, instead of taking this frequency, you modulate के frequency ज़्यादा हो जाती है. If frequency is more, wavelength is less, छोटा एंटेना will work. That's one reason for that. Second reason, first reason हो गया, 3 पूछे हैं. Second reason, फर्स्ट तो ये था कि फॉर इफेक्टिव ट्रांसमिशन द वेवलेंथ का 1/4 इज द एंटेना लेंथ. सेकेंडली, व्हेन यू ट्रांसमिट दैट, द पावर is proportional to 1/square of the wavelength. Again, I'm telling you these details you do not need. At least you have to be able to show that the power of transmission is proportional to 1/square of the wavelength. If that is the case, if I'm reducing the wavelength there, I'm actually increasing the power of transmission there, and that means your signal is going to be able to be transmitted long distances. That is reason number 2. Reason number 3 is very, very interesting. Let's say this is the room and I'm speaking and you're standing over there. You can hear me, right? Because I'm speaking with some frequencies of the range of what humans do speak. Now bring in 2 people here. Both of them are speaking. तुम वहाँ खड़े हो, है ना? थोड़ी sound mix हो जाएगी. Now think about there are 100 people standing in this room and everybody is speaking and you're standing on the far end of the room. Can you really understand what I'm saying? No. क्योंकि you are receiving or your ears are receiving all these sound waves from here. How will your ears know कि मेरी वाली sound waves सुननी? क्योंकि सबकी frequency तो same है यार. So how will you even understand that? And that is exactly reason number 3. When you tune in your radio, let's say you have a radio here. Now big FM, red FM, chili FM, mirchi FM, whatever FMs there are, they're all transmitting. Let's say you're not modulating, you're only transmitting the frequencies that humans speak. Let's say everybody is transmitting the same frequencies. Your radio, what will it tune to? सारी frequency match होके आ जाएगी. And that's why what you do is you give one frequency as the carrier wave. You are going to modulate that signal into a carrier wave. Big FM को एक frequency दे दी, उसमें तुम्हारा signal डाल दिया. Red FM को दूसरी दे दी, उसमें डाल दिया. अब नॉट frequency करी 92.5 FM पे, मेगाहर्ट्ज पे, वो जो भी ट्यून करी उस frequency का play कर दिया. That's it. So let's see how you can present all this in your exam. Practical antenna length, number 1, right? Practical antenna length 3.75 kilometers लंबा थोड़ी एंटेना बनाओगे, और कितने बनाओगे? That's the thing. How many of those? And that's not really practical anyways. effective power radiated proportional to 1 by lambda square, inversely proportional to the square of that. So if you're reducing lambda, you're actually increasing the power transmitted. Number 3 जो मैंने बोला, multiple frequencies. ठीक है. Now this is one of the examples of modulation. This is amplitude modulation. This is the carrier wave. This is the frequency 92.5 megahertz वाली. This is the carrier wave. This is going to carry that signal. This is the message wave. What you're singing, speaking, whatever. This is the message that has to be sent. So this superimposes on this, and it modifies the amplitude. You can see that this is amplitude modulation. Now the envelope of this is the message. और जब receiver पे आएगा, it is going to be able to filter all that. So that technology we are not going into details, but this is the concept of amplitude modulation. And similarly, you should be able to make the graphs of frequency modulation and phase modulation also. The next question is here, show that the voltage gain, this is the last question today, 5 marks, and this is one of the questions that many students think, okay, क्या करना है इतना सारा, क्या derivation है, सब है. So let's see how we can simplify this. This is one of the very simple ways. All you have to do is Kirchhoff rules here. So let me show you how to do that, because this is given in 2 pages or 1.5 pages in the NCERT book, and many students find it difficult. But ये देखो, ये icon इधर आ गया. All you're doing is Kirchhoff rules here. I'll show you how you can do that. तो ये आ गया कॉमन एमिटर्स, है ना, ये तो बनाना आना चाहिए. नाउ यू आर गोइंग टू डू व्हाट, आई टेल यू व्हाट वी आर गोइंग टू डू. दिस इज द लास्ट क्वेश्चन टुडे. दिस इज माय इनपुट सर्किट, दिस इज माय आउटपुट सर्किट. व्हाट इज एम्प्लीफिकेशन? देयर इज अ सिग्नल हियर, फ्लक्चुएटिंग सिग्नल हियर, दैट हैज टू बी एम्प्लीफाइड हियर. सो जस्ट अंडरस्टैंड व्हाट इज इनपुट सिग्नल. इनपुट सिग्नल इज बिटवीन दीज टू, है ना. आउटपुट सिग्नल इज बिटवीन दीज टू. बेसिकली आउटपुट सिग्नल इज सेम एज द पोटेंशियल डिफरेंस बिटवीन C एंड E. तो पहले इनपुट की बात कर लेते हैं. कर्चॉफ रूल, जंक्शन रूल लगाते हैं, जंक्शन नहीं, लूप रूल लगाते हैं. VB से स्टार्ट किया मैंने, तो लेट्स डू दैट. VB से स्टार्ट किया, पहले तो उसको एडिट मोड पे लाता हूं मैं. तो VB से मैं स्टार्ट करूंगा, VB लिख दिया मैं, है ना, पोटेंशियल एट B. अब इधर जा रहा हूं, इट्स माय चॉइस. डू आई लूप इट एंटी क्लॉकवाइज और क्लॉकवाइज? आई एम लूपिंग एंटी क्लॉकवाइज, मेरी मर्जी है. यू कैन लूप क्लॉकवाइज. तो B से यहां में जब गया, तो आई एम गोइंग अगेंस्ट द करंट, सो आई एम गोइंग टू गेन पोटेंशियल. हाउ मच गेन? IB RB. Now because this is the last question here, I'm going to take at least 2 or 3 minutes here and we are going to end the session. तो we come here. अब इधर से इधर गए, we are going from positive terminal to negative terminal. तो negative VBB, अब नेगेटिव VBB आ गए और यहां पे पहुंचे तो VE पर आ गए, इज इक्वल टू VE लिख दिया मैंने. लूप रूल डज नॉट मीन यू हैव टू कंप्लीट द लूप, यू कैन स्टॉप मिडवे ऑल्सो. ठीक है, जस्ट राइट द फाइनल पोटेंशियल इज VE. नाउ थिंक अबाउट दिस. इसमें इनपुट क्या हो रहा है? इनपुट फ्लक्चुएशन, इधर से देखो ठीक से, तो इनपुट फ्लक्चुएशन हैपनिंग अलोंग VBB. This is the input fluctuation. So let's talk about VBB separated out. मैं स्ट्रेटेजी बता रहा हूं, कर क्या करें. VBB को अलग ले जाऊंगा मैं, है ना. तो इसको दोबारा से रीअरेंज करके लिख सकते हैं. VBB, ये देखो VE इधर आएगा तो VB माइनस VE VBE बन जाएगा, है ना. सो दैट बिकम्स इक्वल टू VBE प्लस IB RB. ये इनपुट की लास्ट स्टेटमेंट है, 2 स्टेटमेंट्स ये. अब VBB को क्या करेंगे? फ्लक्चुएटिंग VBB by putting all that signal there, that's fluctuating. So that means that the change in the input voltage. So that you can find delta here. If you find delta VBB, that is the fluctuation in input voltage. Delta VI is equal to VBE का fluctuation. यार VBE तो constant है ना ट्रांजिस्टर में. Potential difference between B and E is a fixed value, so that becomes 0 here. Plus the change in this, delta in this, RB is not changing. So that becomes RB times of delta IB. ये मेरी इक्वेशन 1 बना दी मैंने इनपुट के लिए. सिमिलरली इतना ही सिंपल मैं इनपुट सेकेंड इक्वेशन बनाऊंगा फॉर आउटपुट. लेट्स स्टार्ट विद VC. VC से स्टार्ट किया, उल्टा जाते हैं ऐसे एंटी क्लॉकवाइज. तो VC से स्टार्ट करता हूं, VC पे गया मैं, उसके बाद अगेंस्ट द करंट, सो ICRC, है ना, प्लस ICRC. अब मैं अगेन फ्रॉम पॉजिटिव टर्मिनल ऑफ द बैटरी टू द नेगेटिव, सो अगेन आई एम लूजिंग पोटेंशियल. हाउ मच पोटेंशियल? VCC लूजिंग कर रहा हूं, माइनस VCC, है ना. अब यहां पे आ गया, दैट इज इक्वल टू VE. VE. Now remember what is output. Output we are taking here C और E का, तो E को मैं इधर ले आऊंगा तो VC माइनस VE बन जाएगा VCE. That is output. अब फिर फ्लक्चुएशन की बात करें तो फ्लक्चुएशन इन VCE is actually what the output fluctuation is, output signal. So fluctuation in output is equal to fluctuation in VCC, that's a constant value there, minus RC delta IC. ये हो गया बस खत्म. Now we are talking about amplification here. Amplification is how much is output fluctuating for the input fluctuation. तो अगर input fluctuation इतना था, output fluctuation मुझे इतना चाहिए. That is what amplification is about. How much is the output voltage fluctuation compared to input? तो what we are looking for is delta VO by delta VI. इन दोनों को divide कर दो. What you're going to get is the amplification factor. Delta VO by delta VI is coming out to be minus negative sign. Look at that negative sign. Delta IC by delta IB, वो तो बीटा होता है, और RC है ना, minus of RC over RB times of beta. नेगेटिव की बात करी है उन्होंने, हमने प्रूव कर दिया नेगेटिव. नाउ व्हाट इज नेगेटिव मीन? नेगेटिव एक्चुअली मीन्स यहां पे जो पॉजिटिव साइकिल है दैट इज गोइंग टू बी नेगेटिव साइकिल है, फ्लिप हो जाएगी 180 डिग्री. इट डजंट रियली मैटर. दीज आर साउंड वेव्स. साउंड वेव्स इतनी हाई फ्रीक्वेंसी डजंट रियली मैटर टू यू. ऑल यू गेटिंग इज फ्री, है ना. So this is how you can prove that this is negative. 1, 2, 3, 4, 5, 6, 7 लाइनों में. That's it. And now how you present is it's up to you. But लेकिन obviously this is just 7 lines of proof there. So let's go back and see how we can do that in exam. So here is the circuit diagram back for you, and this is a sample way you can prove that. You don't follow this word to word. You just understand the concept and you present it in your own words, your language, your grammar. So again, this was my last session for the sprint here, and I hope you enjoyed this. Please spread out the word, tell your friends and relatives. These lectures will still be available for free on YouTube channel. So if you missed any of the sessions here, you can always go back, and you can always go back and revise. You can tell your friends, classmates, they can always come back. Make sure you subscribe, क्योंकि ये खत्म नहीं हुआ, पिक्चर अभी बाकी है. वी हैव मोर कोर्सेज कमिंग अप एंड दे विल बी फ्री. दे आर ऑसम. दे आर बेटर मे बी इन दिस. सो मेक श्योर यू प्रेस द बेल आइकन. ऑल्सो शेयर द इंफॉर्मेशन विद योर फ्रेंड्स, and make sure you install the new app that was launched recently, because you can download these slides as a PDF there. So good luck, and I believe in you. You're going to rock the exam. So I'll see you soon. Bye bye for now.